Good evening. Today's quote is: discipline is the bridge between goals and accomplishment. Discipline is the bridge between goals and accomplishment. Today's word is egregious. It is actually uncommon word. What is the meaning? Outstandingly bad, shocking, egregious abuses of copyright. In the last lecture, we discussed about cube roots of unity. Cube roots of unity means roots of which equation? X cube equal to 1. They are 1 omega omega square. What is omega? Omega is a complex cube root of unity. It is either -1 plus I root 3 upon 2 or -1 minus I root 3 upon 2. Note that one complex cube root is the square of the other. Okay, so we say that roots are 1 omega omega square. Now what is the relation between them? Omega cube is 1. This is an important relation. Now from this we can find omega raised to 4. How? It is omega cube which is 1 into omega, that is omega. What will be omega raised to 5? It is omega cube which is 1 into omega square. So finally it is omega square. Another important relation is 1 plus omega square equal to 0. Now remember this basic result. From this we can write 1 plus omega equal to minus omega square. Omega plus omega square is what? -1, and 1 plus omega square is nothing but minus omega. Okay, so this is about complex cube root of unity. Now sum number 5. I think this is exercise 1.3. Am I right? Exercise 1.3, and we are doing sum number 5. Let me read the sum for you. If x is a plus b, y is alpha a plus beta b, and z is alpha beta plus rather a beta plus b alpha, where alpha and beta are complex cube roots of unity, then show that xyz is a cube plus b cube. Okay, write down. Write down. As alpha beta. Okay, this is exercise 1.4. I'm sorry. This is exercise 1.4. Okay. Now I have corrected this. Write the solution. Alpha beta are complex cube roots of unity. Alpha beta are complex cube roots of unity. Therefore, we take alpha equal to omega, beta equal to omega square. Okay. So tell me what will be xyz. Substitute the values. A plus b into alpha a, that is, I will write a omega. Okay, I'll repeat this. I'll tell you the solution from the beginning. Write down. Alpha beta are complex cube roots of unity. Alpha beta are complex cube roots of unity. Therefore, alpha equal to omega, beta equal to omega square. Now see on the screen, xyz equal to, substitute the values. So a omega plus b omega square. Actually, we have done this now because the previous sum was of this type only, into alpha, rather a alpha square. What is that? X, Y, Z. Yes. So it is a beta. So a omega square, please check this, plus b omega. Yes, this is correct. That is a plus b. Now here open the brackets. So this is a square omega cube plus ab omega square plus ab omega raised to 4 plus b square omega cube. Now write down omega cube is 1. So omega raised to 4 is omega cube into omega, that is 1 into omega equal to omega. So xyz is a plus b into what? A square into 1 plus ab omega square plus ab omega. Why? Because omega raised to 4 is omega, plus simply b square. Why? Because omega cube is 1. You can also say b square into 1, same thing. So this is a plus b, that is a square. Now take ab common to get in bracket omega plus omega square, bracket complete, ab plus b square. Now what is 1 plus omega square? 0. And therefore this is nothing but, initially I will write directly and then I'll explain y minus 1. So minus ab plus b square. Note that these are the factors of a cube plus b cube. So this is a cube plus b cube. I have to mention the reason. 1 plus omega square equal to 0. Therefore, omega plus omega square equal to minus 1. Okay, right. Now, this is interesting part. Actually, you require this in higher mathematics, that is in engineering. But let us discuss this. The title is Set of Points in Complex Plane. If z equal to x plus iy represents the variable point pxy, and z1 equal to x1 plus iy1, z2 equal to x2 plus iy2 represent fixed points ax1 y1 and bx2 y2, then actually you haven't done the concept of locus. So all these are loci, plural of locus. Then modulus of z minus z1 represents the length AP. I'll explain why, rather how. See, this is z1 and this is z2. Can you tell me what is z1 minus z2? We will write that. See, even if after explanation, I'm sure you will understand, but if you do not, just forget this because this won't be asked. See, what is z1? It is x1 plus iy1. Okay. What is z2? It is x2 plus iy2. Can you tell me what is z1 minus z2? It is x1 minus x2. This is real part, plus I, y1 minus y2. Now can you tell me modulus of z1 minus z2? It is root of what? Square of real part plus square of imaginary part. You have studied distance formula. Note that this is nothing but the distance between 2 points, say P and Q, representing these complex numbers. See, mod of z minus z1 represents the length AP. Actually, they have taken A and P, that is this complex number x plus iy and x1 plus iy1, and that is why they are getting this root of x minus x1 square plus y minus y1 square. So this is nothing but distance formula. Second, mod of z minus z1 equal to a represents a circle with center at x1 y1 and radius equal to a. I will prove this. This is interesting. Basically, can you tell me what is the equation of this circle whose center is at x1 y1 and radius is a? Pxy is point on the circle. Now every point on the circle is at a distance radius from the center. So what is Cp, or what is Cp square for that matter? X minus x1 square plus y minus y1 square, right? But Cp square is nothing but a square. Yes, this represents circle. Now they say mod of z minus z1 equal to a represents a circle. Let us verify this. Mod of z minus z1 equal to a. Now, what is z? Z is x plus iy. And what is z1? It is x1 plus I y1. Now we will do this part orally. What is z minus z1? X minus x1 plus I in bracket y minus y1. What is the modulus of that? It is root of x minus x1 square plus y minus y1 square equal to a. Now, if you square this, see, I have written this only. If you square both the sides, you get this only. X minus x1 square plus y minus y1 square equal to a. So this represents a circle. Now, one student is asking, are we supposed to remember this? No. It is sufficient if you understand the explanation part, more than sufficient. Now, mod of z minus z1 equal to mod of z minus z2 represents the perpendicular bisector of the line joining points A and B. Okay, this is the third part. See, these are the examples. Basically, this part should be taught after the topic locus. What is locus? Locus is set of points satisfying certain geometrical condition or conditions. One student is asking, sir, what is the meaning of represents a circle? See, for different points P, rather as P moves in such a way that its distance from A is always fixed, this describes or represents a circle. Or you may say this equation, mod of z minus z1 equal to a, this equation represents a circle. Okay. Now see the illustrations. Z1 is 3 plus 5i, Z2 is 2 plus I, and Z is x plus iy. What is mod of z minus z1? It is mod of x minus 3 plus y minus 5i. Now modulus of complex number is obtained by taking root of sum of the squares of real part and imaginary part. Note that this represents the distance between which points? X, y and 3, 5. You have already done distance formula. Is that clear? So this is about set of points in complex plane. Question 6. Find the equation in Cartesian coordinates of the locus of z if. Now, what do you mean by Cartesian coordinates? X and y are called as Cartesian coordinates. So in terms of x and y. Now we will be doing first one. What is that? Modulus of z equal to 10. So we begin with, write down, let complex number z be x plus iy. Now if you ask, sir, can we take it as a plus ib? No, because a and b are not Cartesian coordinates. X and y are Cartesian coordinates. Okay, so let z be x plus iy. Then modulus of z equal to 10 gives modulus of x plus iy equal to 10. Can you tell me modulus of x plus iy? Simple. It is just root of x square plus y square equal to 10. On squaring both sides, you get x square plus y square equal to 100. What does this equation represent? This represents circle. Of course, you are not supposed to mention that. If you mention, it is well and good. But even if you do not mention, because at present you are not supposed to know that this represents a circle, because we'll be doing circle in second semester. So you are supposed to write this is equation. Right down. This is equation of required locus. I'll again explain the meaning of locus. Don't worry. See, locus is set of points. Now, when I say set, means there must be some method, there must be some rule by which elements are written. What is that rule? How will you explain this in words? Sum of the sum of the squares of x and y coordinates is always constant and it is 100. So this is the speciality of the locus, set of points satisfying which geometrical condition? The geometrical condition is sum of the squares of x and y coordinates is always 100. Actually, if you come to know that this is a circle, you will say that geometrical condition is, as you know, that every point on the circle is at a fixed distance from fixed point. Fixed point is center, which in this case is actually origin 0 0, and this is point pxy. Okay, I repeat, in exam you are not supposed to mention this. Right now, this is the first part. Can you tell me the second part? Mod of z minus 3 equal to 2. Now it is z. It is x plus iy minus 3 as it is. Equal to 2. I'm sorry. Mod of z minus 3 is given to be 2 in textbook, not 3. So this is 2. This is 2. Pardon me for my bad handwriting. This is z and this is 2. Okay. Now, which is the real part? X minus 3 is the real part. Plus iy equal to 2. This is not at all difficult, because we have done concept of modulus of a complex number. Now, what is modulus of this? It is root of x minus 3 square plus y square equal to 2. Square both the sides. On squaring, you get x minus 3 square plus y square equal to 4. Below that, write down, this is the equation of locus. This is equation of locus. Again, locus is set of points satisfying certain geometrical condition or conditions. At present, for this locus, you won't be able to understand or find the required condition, because we haven't done the concept of locus yet. This will be doing in second semester. But at least we can obtain the equation, right? Now, third part, not for homework, but you have to type your answer in chat box. What is that? I begin with let z be x plus iy. What is given? Modulus of z minus 5 plus 6i, okay, equal to 5. Type your answer in chat box. Tell me the equation of locus. So mod of z minus 5 plus 6i equal to 5 means x plus, rather modulus of x plus iy minus 5 plus 6i equal to 5. Now the real part is x minus 5 and imaginary part is what? Y plus 6. How to get that? Take I common. Now what is the modulus of this complex number? Root of x minus 5 square plus y plus 6 square equal to 5. On squaring you get this. Now, you are not supposed to write this in exam, but I think after explanation you will understand this. This locus represents a circle whose center is at 5 minus 6 and radius is 5 unit. You can check this. Pxy is any point on the circle. Every point on the circle is at a distance radius from the center. And by distance formula, what is Cp square? This only. Okay. Now, just listen to me. You have to write the solution after the lecture. Fourth one, what is given? Mod of z plus 8 equal to mod of z minus 4. Replace z by x plus iy. So, on left hand side, complex number is x plus 8 plus iy. And on right hand side, complex number is x minus 4 plus iy. Their moduli are the same. So find out modulus of each. On squaring both sides, you get x plus 8 square plus y square equal to x minus 4 square plus y square. Open all the brackets, simplify to get x plus 2 equal to 0. This is the equation of the required locus. One student is asking, now tell us what does this equation represent? Okay, I can tell you. You have done this in 10th standard. See, this represents a line which is parallel to x-axis, y-axis. Take any point on this line. Take any point on this line. Its x coordinate is always 2. I write here 2, 0. So what does x equal to 2 represent? It represents a line which is parallel to the y-axis. Again, you are not supposed to write this in exam if asked. This sum won't be asked in exam. Okay. Fifth one. What is given? Mod of z minus 2 minus 2i is mod of z plus 2 plus 2i. But z is x plus iy. Write both complex numbers in standard form, that is a plus ib form. Now modulus is root of square of real part plus square of imaginary part. On squaring and simplifying, you get x plus y equal to 0. So y equal to minus x. You need not write y equal to minus x. Just write x plus y equal to 0. Again, what does this equation represent? X plus y equal to 0. You have done this also in x plus y. Just let me check. X plus y equal to 0, right? Okay. What does this equation represent? It represents a line. Now this line definitely passes through origin because 0, 0. Satisfy the equation. Suppose x coordinate is 1, then what is y coordinate? It is minus 1. So x coordinate is 1, y coordinate is minus 1. So this is the line. This is the line whose equation is x plus y equal to 0. Is that clear? So locus is a line. Again, this is not required. Then sum number 6. Z is x plus iy. What is given? Mod of z plus 3i upon mod of z minus 6i equal to 1 gives. Now replace it by x plus iy. Okay. Now cross multiply, or you may say first that what is modulus of quotient? It is modulus of numerator upon modulus of denominator, and then cross multiply. Now you know how to find the modulus. Rearrange the terms to get this equation. 2y minus 3 equal to 0. What does this equation represent? It represents a straight line. 2y equal to 3, right? 2y minus 3 equal to 0. So y equal to 3 upon 2. See, I'm explaining this because you had done the topic lines in 9th or 10th standard. See, this is the line y equal to 3 by 2. It is parallel to x-axis. Take any point on this line. Its y coordinate is always, x coordinate varies, but y coordinate remains the same. Yes. Now 7 sum is based on this De Moivre's theorem. Cos theta plus I sin theta raised to n is cos n theta plus I sin n theta. We will use this n for any real number. Basically in this exercise for any integer. Okay. I have already told you that we are going to prove this using method of induction in the second semester. What is that? Cos theta plus I sin theta raised to n equal to cos n theta plus I sin n theta. Now, sum number 7, first part. Use De Moivre's theorem and simplify the following. Okay. So, it is, write down, cos 2 theta plus I sin 2 theta. Please do not read this as cos into 2 theta. This is not multiplication of cos and 2 theta. This is actually cosine ratio of angle 2 theta. In short, we read this as cos 2 theta. Okay. Raised to 7 upon cos 4 theta plus I sin 4 theta raised to 3. Can we use laws of indices directly? We cannot, because angle in the numerator is 2 theta and angle in the denominator is 4 theta. See what we can do here. Now can I write this as cos theta plus I sin theta square? Yes, we can. Raised to 7. You can verify. See, what is cos theta plus I sin theta raised to 2? It is cos 2 theta plus I sin 2 theta, because see the result. It is cos n theta, where n is index. Here index is 2. So 2 theta. So we have written the same in required or desired form, so that we can apply laws of indices. Similarly, what about denominator? It is cos theta plus I sin theta raised to 4 raised to 3. Why this is so? Because raised to 4 is for cos 4 theta plus I sin 4 theta and its index is 3. Next step, laws of indices. So this is cos theta plus I sin theta. I'm talking about numerator. A raised to m raised to n is a raised to mn. So raised to 14. What about denominator? Cos theta plus I sin theta raised to 12. Same logic. Now can I apply laws of indices? Yes, I can. So this is cos theta plus I sin theta raised to, what is 14 minus 12? 14 minus 12 is 2. Now again, De Moivre's theorem. So this comes out to be cos 2 theta plus I sin 2 theta. That's it. I'll explain this once again. Now in the second sum, we are going to use the result. Cos of minus theta is cos theta, but sin of minus theta is minus sin theta. Means minus sine theta can be replaced by sine of minus theta. Cos theta, if required, can be replaced by cos of minus theta. So cos phi theta plus I sine phi theta using de Moivre's theorem. Please write the reason. Give credit to that gentleman, de Moivre's theorem. So this is what? Cos theta plus I sine theta raised to phi. What about denominator? Cos 3 theta can be written as cos of minus 3 theta plus sine of 3 theta is what? Sine of minus 3 theta raised to 2. Now, this is interesting. N is minus 3. So for this part inside the bracket, I can say cos theta plus I sine theta raised to minus 3. But original index 2 as it is. A raised to m raised to n is a raised to mn. Now a raised to m upon a raised to n is a raised to m minus n. I have directly written, it is better if you say 5 minus minus 6, that is 5 plus 6, which is 11. Now cos theta plus I sine theta raised to n is cos n theta plus I sine n theta. N is 11. So this is the final answer. Just listen to me, but please do write the solution after the lecture. Cos 7 pi by 13 plus I sin 7 pi by 13 raised to 4 upon cos 4 pi by 13 minus I sin 4 by 13 raised to 6. Observe this. See, in all the angles, pi by 13 is common. This is basically 7 times pi by 13 and this is 4 times pi by 13. Okay? Yes. Now this is nothing but cos of theta is cos of minus theta. Minus sine theta is sine of minus theta. We have used this. Now this is interesting. See, cos 7 pi upon 13 plus I sine 7 pi upon 13 is cos pi by 13 plus I sine pi by 13 raised to 7. Check this. Cos theta plus I sin theta raised to 7 is cos 7 pi by 13 or 7 theta in general. Yes. Now you'll ask me why 4? It is there from the beginning only. So one step is omitted here. So raised to what? 7 into 4. Now cos of minus 4 by 13 plus I sin minus 4 by 13 is cos pi by 13 plus I sin pi by 13 raised to minus 4. But already 6 is there. So into 6. Now this is cos pi by 13 plus I sin pi by 13 raised to what? 28 minus minus plus 24, that is 52. Now cos theta plus I sin theta raised to n is cos n theta. N is 52. Theta is pi by 13. So cos of 52 pi by 13 plus I sin 52 pi by 13. Cos 4 pi plus I sin 4 pi. Now sin 4 pi equal to 0. Cos 4 pi is 1. So final answer is 1. I'll tell you the logic for this. Let me explain. 4 pi means what? 2 pi, 360 degrees, one complete rotation, 2 pi. So 4 pi trigo ratios for 4 pi are same as trigo ratios for 0 degree. Cos 0 is 1. And what is sin 0? It is 0. I can tell you the logic for this. If you remember, what is sin theta? It is y. What is cos theta? It is x. If a point lies on x-axis, y coordinate is 0. So sin theta in this case, that is sin 4 pi. 4 pi means what? One complete rotation, 2 pi, that is 360 degrees. Two complete rotations, 4 pi. 720 degrees, that is 4 pi radian. So corresponds to 0 degree, and that is why sin 0 0, but cos 0 is 1. If you haven't understood this, just remember that cos 4 pi 1, sin 4 pi 0. So the final answer is nothing but 1. Sum number 8. Actually, the image is blur, but I'll read the solution for you. Express the following in the form a plus ib, where a and b are real numbers, using De Moivre's theorem. First part, 1 minus I raised to 5. Let z be 1 minus I. Let z be 1 minus I. See the cursor. This is of the form a plus bi, where a is 1. This is not minus. I'm going to change this. A is 1 and b is minus 1. Now what is r? Modulus of complex number. It comes out to be root 2. What is cos theta? A upon r. And sin theta? B upon r. Now cos theta is 1 by root 2, sin theta is minus 1 by root 2. This is important. Theta is in fourth quadrant. Why? Because the point which represents 1 minus I is 1 comma minus 1. X coordinate is positive, Y coordinate is negative. So point is in fourth quadrant, and therefore tan theta sin by cos is minus 1. So that angle is 7 pi by 4. You have to remember this as it is. Again, I'm repeating that. We'll be doing this in the topic trigonometry, but I hope you can appreciate this. In fourth quadrant means what? Angle is more than 270 degrees, but less than 360 degrees. If you want, you can convert this into degree, 315 degree, 315. Okay. Now what is Z? It is r into cos theta plus I sin theta. I hope you remember this polar form. So root 2 cos 7 pi by 4 plus I sin 7 pi by 4. Now original complex number is 1 minus I raised to 5. So raised to 5. Is that clear? So it is root 2 raised to 5. Now this is basically, you have to multiply it by what? Multiplied by 5. Okay, I'll explain this part. First I will read this. So this is root 2 raised to 5 cos of 2 pi minus pi by 4 plus I sin 2 pi minus pi by 4 raised to 5. What is cos of 360 minus theta? Cos theta. This is a theorem which we'll be studying in trigonometry. Sin of 360 minus theta is minus sin theta. So this reduces to this one. Then apply De Moivre's theorem. Cos pi by 4 minus I sin pi by 4 raised to 5. So it is 4 root 2. Why 4 root 2? Product of root 2 5 times is 4 root 2. Okay. And cos of 5 pi by 4 minus I sin 5 pi by 4. What is the next step? Next step is this one. Actually, what is cos 5 pi by 4? It is minus 1 by root 2. And what is sin pi by 4? It is 1 by root 2. So on simplification, you get minus 4 plus 4i. See, even if you say, sir, we couldn't understand this, it's fine for so many reasons. Or I can say that you will not understand because trigonometry part is not done. Here allied angles are used, so many things are there. So just remember that answer is minus 4 plus 4i. Okay. I think we should discuss sum number 8 once we complete trigonometry. Okay. So we stop here. In the next lecture, we'll be doing miscellaneous sums.